Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now going to be answering this question, which is question number 19 from the May-June 2006 IGCSE Cambridge Paper 2 from the 0580 syllabus. This is an extended paper, very old paper here. But this question is quite a useful question in trying to explain some different types of factorizing, which is my objective in this video. So this question here has, first of all, part A, we have to factorize 4x squared minus 9. Now, whenever we have to factorize something, we should always, first of all, the first thing we should do is check, are there any common factors in the terms that we can write outside the bracket, and then, what we then have to factorize will normally become a lot simpler. Now, in this case, there are no common factors in the two terms of this expression. Okay, so when we see two terms in an expression and a negative between them, then straight away in our mind should, the idea that it could possibly be a difference between two squares should come into our mind. So we have two terms, a minus sign between them, could be a difference of squares. Okay, now if you have a difference of squares, what happens, it factorizes into a particular format. Because, for example, if I have this format a plus b times a minus b, and this pattern is found by recognizing the patterns of expanding. If I expand something like this, you end up with a squared minus ab and plus ab, b times a plus ab, and b times minus b, which is negative b squared. And these middle terms, they cancel out because you've got the same thing, one positive, the other one negative. So you end up with this a squared minus b squared. So if we're thinking in reverse, when we have a difference between two square terms, you end up with two brackets, the square root of each of these terms inside those brackets. One of the brackets has a positive sign, the other one has a negative sign. So recognizing the patterns that we get when we expand help us always to factorize. So this is a pattern like the difference of squares. It's called the difference of squares, or difference between two squares, because this minus sign is between two square terms. Anytime you see something like that, you always straight away, you can just put it straight into two brackets. You write the square root of each of these numbers inside those brackets. So you have 2x and you have 3. Square root of 9 is 3. 2x again and 3. And then in one of the brackets you put positive, the other one you put negative. It doesn't matter which way round. You could put minus here and a plus there, no problem. But you end up with your answer. So this pattern, that is found by recognizing what happens when we expand, helps us, of course, to do the reverse, which is to factorize. So this is called a difference of squares. So there's part A completed. Now part B, at first sight, you might think it's similar to this, but what I mentioned first is we should always take out a common factor. And even if we try to proceed using this method, the problem is all the terms must be squared terms. Now in this case, x squared is a squared term. Any letter to an even power is a squared term. For example, even if it was 4x to the power of 6, that's the same as 4, and the x can be written as to the power of 3 and then squared by the laws of indices. That's the same as this. So this is actually a squared term. This, if you think about this, is actually 2x cubed all squared. This will give us 4x to the power of 6 if you expand it. So this, even if that was a 6 or a 4 or 8, you'll end up with a perfect square. But if the letter term has an odd power, then that's not a square term. And here we have the x having a power of 1. It's not written, but there's a 1 there. So this is not a difference of squared because this x is not a squared term, so I can't use the same method. But as I mentioned in the beginning, the first thing you should always do anyway is to try to take out common factors. It always makes life easier for you and makes this thing possible. So first of all, I'm going to take out the common factor of x. All right, so x goes into both of these, so I'm going to take it out as a factor. I know that x times something gives me 4x squared. Well, that's 4x. And x times something gives me negative 9x. Well, that's negative 9. Now we have this where we don't have a difference of squares, although 4 and 9 are both square terms, the x here inside here is not a square term. So therefore, our answer is simply x times 4x, take away 9, and there's the answer for part B. So it's not a difference of squares, whereas this is. Okay, part C now. This is a type of question where there's different methods that many people use, and everyone has their own little method or whatever. You can split the middle term, you can use like this scissor method, I like to use what I call the window method, but all of these are basically formed, all these methods are formed by recognizing again the patterns that you get when you expand a pair of brackets. Okay, now this isn't the type of quadratic equation or expression, where the coefficient of the x squared is not 1. Okay, if the coefficient of x squared is 1, for example, if I had x squared, say minus 7x plus 12, something like that, then if there's a coefficient of 1 here, then that simply just will factorize straight away into two brackets. No need to split the middle term. You know that x times x is x squared, so that's the only option there. You know that these two numbers will definitely multiply to give you that number, and when you add them, you'll get that number, because when you expand this, it will be x times this number and then x times this number, so those two numbers have to add up to -7. So we can quite quickly deduce it's going to be -4 and -3. Those multiply to give you +12 and add to give you -7x, and that's how you get your answer. And we get that by basically doing the reverse of expanding. When we reverse of factorizing, when we expand this, we'll see we get x squared minus 4x plus 3x, minus 3x and plus 12. So these two add up to give you this number. Okay, so you have x squared minus 7x plus 12. So this number is the sum of these two numbers, and this number is a product of those two numbers. And that's a pattern that we recognize. Now that pattern doesn't quite work when we have two brackets that we multiply, where one of the x terms or both of them is not 1. Right? For example, if I have 2x plus 3 times, say, even x minus, say, 4, when I multiply these together, I'm going to get 2x squared minus 8x plus 3x and minus 12. So now notice that the sum of these two numbers is going to be -1, but the sum of these two numbers is not -1. So the middle term is not the same as the sum of these terms in the case where you have a number that's not 1 in front of one of the x terms in the bracket. So finding two numbers whose sum is this and whose product, whose sum is like basically 2x squared, this minus 5x minus 12. Okay, so finding two numbers whose sum is this and whose product is that won't work in this case. Okay, it won't work in this case. Here we have to do something slightly different. And again, we can deduce what to do by looking at some of the patterns that we get when we do expand brackets. So I'll just show you an example of how this works. What I like to do to show this example, okay, is to use like this like window method, this block. So I'm going to first show you what happens when we expand. Okay, so when we expand using the window method, and then I'm going to show you what the patterns we recognize from it are, and then we can deduce how we can do the reverse of expanding, and we'll apply that to this to factorize it. Okay, so this is of course a lot longer what I'm going to do explaining to you in terms of just giving you the whole background behind this method that I'm going to teach you, because I like people to understand what I'm doing and why you're doing it. Of course, it won't take you that long in an exam because I'm going through the whole foundation of it, and then I'll show you how to apply it, and it's really easy and quick. Hopefully you find it really easy. So if we expand, like if we do 2x minus 3 times x plus 4. So to expand that, what I'm going to do on the right, like each of these little blocks represents a little rectangle. So for example, if I want to find the area of this rectangle, it's going to be 2x times x, which is 2x squared. And this is going to be minus 3 times x, which is minus 3x. And this block here is 2x times 4, which is 8x. And this little block here is 4 times minus 3, which is -12. So altogether, we end up with 2x squared plus 8x, okay, plus 8x minus 3x and minus 12, which gives us 2x squared plus 5x minus 12. Okay, so that's what happens when you expand this using the grid. You get, of course, the same answer as you would just normally. But what we can notice here, what this helps us to realize is that there are some patterns that exist. If I think about what the product of these two numbers is, the product of these two numbers is negative 24x squared. If I think about the product of these two numbers, it's also negative 24x squared. And that will be the same for any pair of numbers or brackets that you multiply in the same way. You'll notice that the product of these two diagonals will be the same as the product of those two diagonals. That's one thing to notice. The product of the diagonals is the same. Okay, so the one thing we realize from the pattern is the product of the diagonals is equal in both diagonals. Okay, so that's one thing that you notice. The second thing we notice is that these two terms here, this 8x and minus 3x, they will add up to give you the middle term that you get in your expansion. Okay, so you can say this second diagonal here made up of the x terms add up to give you the middle term. Okay, so one diagonal, okay, without the x squared one, but actually the x ones, the x terms, say the x term ones, okay, the sum is the middle term, the x term of the expansion. That's the other thing we notice. And the other thing that will really help us here is what you notice is each number at the, for example, on top of this column, this number here, it's the highest common factor of the two numbers below it. This number here is the highest common factor of the two numbers below it. This number here is the highest common factors of the numbers in the row next to it. So the ones on the left of the rows, they're always the highest common factor. X is the highest common factor of 2x squared and minus 3x, and 4 is the highest common factor of 8x and minus 12. So when we realize that at the head of each column and row, we have the highest common factor of the terms in that column and that row, those three facts together will help us to factorize anything of that form. Okay, so let's now apply that to this particular question. So that was just a little background information to get you prepared for this method that I'm going to explain to you now of how to factorize using this. So what I'm going to do is I'm going to start off, and you always start off in this way, and I'm going to put here 4x squared and plus 2, because those are the two numbers that come up in our grid. We can place them straight away. Okay, it's always the x squared term and the constant term that you can put straight away in the top left and the bottom right of this grid. Then we say to ourselves the product of these terms is going to be 4x squared times 2, which is 8x squared. So I know that the product of these terms must also be 8x squared. So these terms, they multiply to give you 8x squared, but I also know that the sum of these terms must be negative 9x. So what numbers will you multiply to give you together to give you a positive sum and a negative, sorry, a positive product and negative sum? Well, one of them has to be positive and the other one has to be negative. One has to be positive and the other one negative. The sum has to be negative 9x and the product has to be 8x squared. So one of them is positive, one of them is negative. And how do you get 8 as a product? Sorry, both of them must be negative because the product is positive, so they both must have the same sign. And when you add them together, you get a negative value. So that means they must both be negative numbers. Okay, so just ignore what I just said a minute ago. So because the product is positive, you only get a positive product when you multiply two numbers which have the same sign. So they could either be positive or negative, both of them. But then when you look at what their sum should be, it's a negative sum. That means they both must be negative numbers. And how do you get 8 as a product and 9 as a sum? Well, that's 8x and 1x, sorry. 8x and 1x. So it's minus 8x and minus x. Those are the two numbers. When I multiply them together, I get positive x squared, 8x squared. When I add them, I get negative 9x. All right. The other possibility would have been 4 and 2, minus 4 and minus 2. They give us the correct product, but they'll give us, if I add them together, negative 6x. So they won't work here. So I'm going to write, and I can put them anywhere I want. I can put them here or, either one in these two places. Let me write the minus 8x here and the minus x here. I could have done it the other way around and we'll still get the same answer in the end. Now what I do is I use the third fact. So now we've used the fact that these two numbers multiply to give you the same as the product of these two, and these two numbers add up to give you this sum, minus 9x. So we found those two numbers. Then we use the fact that at the head of each column and at the left of each row is the highest common factor of the numbers in that column or that row. So let me take this row here. I see I've got 4x squared and minus 8x. The highest common factor of those two is 4x. I know I have to write 4x over here. Now, once I've found one of them, I don't have to think about the common factors of the rest. I can just use the fact that this rectangle here has an area of 4x squared. How is that going to be? This side is 4x. This must be x. 4x times x is 4x squared. And this rectangle here has an area of minus 8x. 4x times something gives me negative 8x. That's negative 2. And this rectangle here has an area of minus x. This side is x. This must be negative 1. That's a much easier way. Once you've got one of them using highest common factor, that's a very easy way of getting the others without having to think about highest common factor again. Especially with negative signs and stuff, people get confused. So that's way easier to just do it like that. So now we have got the two factors. We know that this whole rectangle is given by this side times that side, which is 4x minus 1 times x minus 2. Okay, so I went through this in a, I went through this in such a way that you understand why I'm using this grid and what the significance of the numbers on the sides of the grid are. Three things. These two, you always write this, the first term, the x squared term, and the number term in these two places here. Then you always think about what's the product of these two. The product of those two must be the same as the product of those two, so it must be 8x squared. And the sum of these two is always the same as a middle term, so they add up to negative 9x, so you end up with minus 8x and minus x. And then you use the other fact that at the head of each column and the left of each row is going to be the highest common factor of the terms inside the row. So you find one of them, and then you can just use simple multiplication to find the rest of them. 4x times something gives you 4x squared, and so on. And what you're left with on the outside, on the left and the top of the grid are the two factors of the expression. So we have now finished. You can check your answer: 4x squared minus 8x minus x, which is minus 9x, and plus 2. So that's one method of factorizing using this, this method of these grids. You can also use this method if you want, where you split the middle term, which is very similar. You know that this term splits up into two parts. One part is exactly the same way. They must both multiply to give you 8, and they must both add to give you minus 9x. So 8x squared and minus 9x, again, it's going to be minus 8x and minus x. And then you use factorizing by grouping. So you basically just take the first two terms of this and you factorize. The common factor here is 4x. We'll take the highest common factor. That's going to give you x minus 2. Then you put your sign that comes next, and then you look at these two. There's no common factor in these two, so you have to take out 1. So if you look at these two terms, the highest common factor, you can call it 1. So minus 1 times something is minus x, that's x. Minus 1 times something, that's plus 2. That's going to give you that's going to be minus 2. Because minus 1 times minus 2 is plus 2. Then we can see that there's a common factor. Okay, here the common factor are in both these terms are the x minus 2. That's a common factor in both these, you can say these two big terms here. So you can take that out as a common factor. So you have x minus 2, and then in brackets 4x minus 1, and you get your answer. It's the same as that. And that's another method of doing it. And you can also go commando style, where you do some sort of guessing and checking. So you think to yourself, okay, I need to have two brackets. I know that there's going to be both the same signs, and because you add the numbers together, you're going to be negative. They're both going to be negative signs here. I know that. I know I have to end up with positive 2. The only way of getting 2 is 2 times 1. So it's negative 2 times negative 1. So those things I can work out straight away. Then I've got to decide what goes in these two. So I could have both of them as 2x, or one of them as 4x and one of them as x. Those are the ways of getting 4. If I put them both as 2x, for example, just imagine I put them both as 2x. You're going to have 4x squared, which is fine, but then you have minus 2x and minus 4x, which is minus 8x. I want minus 9x. That's going to be minus 2x, sorry, minus 6x. Minus 2x, minus 4x, that'll be minus 6x. I want minus 9x, so that doesn't work. So the 2x's won't work, so I get rid of those. Then I think about 4 and 2. Now, I know the 4x is going to go here, but supposing I put it here instead. 4x and x, that gives me 4x squared. That's another combination. But if I put it like this, it's going to be 4x squared minus 4x minus 2x. Again, that's going to give me negative 6x and not negative 9x. So then I say, okay, it must be the other way around. It must be that I have my x here and my 4x there. And then you see you get 4x squared minus x minus 8x and plus 1, which gives you the right answer. So that's kind of like where you just go straight away and try to find the combinations that work. And in some questions it's really easy. In this one it's not too difficult at all. But some questions when there's lots of combinations of how to get this number and lots of combinations of the product of these two, then there's a problem. And for splitting the middle term, you always try to find the product which is the same as these two multiplied together and the sum which is the same as this. And it's based on the same pattern that we saw here, that the product of these two is the same as the product of those two, and the sum of these two numbers here is the same as this number here. So basically we're finding two numbers whose product is the sum of these two and whose sum is the same as this middle term. So it's based upon the same thing as this is, and that's how you split it up in the same way as we split this up. Okay, but it's just a slightly different method because you have to use grouping here, whereas here you just take out the common factor of one of them, you can work out the others easily. So they're all kind of related to each other. Okay, you have your guess and check, you have your split your middle term, and you have your window method. They're all perfectly correct methods in answering such a question. So sorry for going on a bit on this question, but I just wanted to go through the explanation of this type of question in a bit more detail, starting from how we the foundation of it. How do we end up with these methods? We end up with these methods by looking at the patterns that we find when we do the opposite, which is expanding. And that's how we come up with these methods here of factorizing, which is the reverse. Okay, so I know it took a bit long, but this is just to help the students understand the background of it. Thank you for watching other questions from this particular paper. If you're interested in watching the other questions that I have answered from it, you can find in the playlist that will appear somewhere over here. If there is a question from this or any other paper from the Cambridge IGCSE exam papers which I answer, you can request me to answer them, and I'll try and do so as soon as I get time. You can also see other questions dealing with factorizing and algebraic manipulation in the playlist over here, and you can subscribe to my channel by clicking on this link. If you're interested in A-level material, go to the description of the video and click on the links that you find there. Thank you for watching, and see you soon.